Okay, hi guys. So this is my video to help you guys on the asynchronous day since I won't actually be there, and we start our training in about 40 minutes. So I'm going to start this video to help you out. So let me share my screen so you guys can see what I'm doing. All right, so I have up on my screen what we did the other day, which were our notes. Remember, you guys had this written down. I have this presentation up also in today's week for Canvas. Make sure that you have checked in so that way you can get attendance for today. So if you remember, a tangent line and the radius will meet at a 90-degree angle, right? It'll always make a right angle. This is really important because this is why we can use the right triangle information to solve these things. And then if I have two tangents that meet at some point outside of the circle, then the tangent lines that they make have to be congruent. Okay, and if you remember, from A to the center and from B to the center right here, where's my cursor? From A to the center and B to the center, these both are congruent because they're both radiuses. Okay, hold on. Okay, so we're going to use both of these things and some previous information to solve all the questions from the IXL that you're supposed to be completing today. I also wanted to remind you about this. So when you're solving right triangles, okay, if you have two sides and you want the third side, then you should use Pythagoras. Okay, you should use Pythagorean theorem. If you have one side and an angle, you should always use a trig function, whether that's finding another side or finding another angle. So if we have side lengths and we need an angle, we use trig functions. If we have two angles and we need the third, we can use the triangle sum theory. That's its name, but this is what it looks like. The sum of all three interior angles of a triangle will add to equal 180 every single time, no matter what the triangle looks like. As long as it is a triangle, this works. Okay, so let me go to a different screen share because I have a document camera that I'm using so I can show you how to do these things. All right, here we go. So this is just some practice questions. I actually stole these directly from the IXL, that's where I got them. And I drew them on here with some tools, which is why it looks so pretty. So I'm gonna start with this one up here that says, find the measure of angle P, okay? So I want this measure right here. I'll put a little X next to it. So I want this angle measure, okay? Well, if I'm dealing with angle measures, remember, then I need to go to the second slide of that PowerPoint, which says that I'm supposed to either use sine, cosine, tangent, one of the trig functions, or I use the sum of the three interior angles is 180. It depends on what I have. So do I have any side lengths? I see I have no side lengths. I just have this one angle right here. So because I have no side lengths, it can't be a trig function. Okay, I can't use a trig function. I have to be able to get another angle. Well, I have a theorem that says where my tangent line meets my radius is a right angle. So this right here is a right angle. Okay, if you remember that all right angles are 90 degrees. So I have two of my three angles. So I know that 90 plus 56 plus whatever the angle I don't know is supposed to equal 180. Okay, it's supposed to equal 180. So 90 plus 56 is 146. Okay, so what number plus 146 equals 180? Okay, well, if you can't come up with that off the top of your head, just subtract. So 180 minus 146. Okay, so I'll borrow from the 8. 10 minus 6 is 4, 3. So X had to be 34 degrees. So my angle P is 34 degrees. Okay, so the measure of angle P equals 34 degrees. Now you do not have to type in the degree symbol on IXL. They actually already have it sitting there. So this is how you'll solve one if you've got just like one angle shown, because you know the second angle. The second angle is that 90-degree angle. So you have two angles and you need the third. So we will use the triangle sum theorem. So I have two angles. I need the third angle. Okay, it's important to always identify what you have and what you need. Okay, so I'm going to move on to this one down here. Okay, so I can see I have this side length is 5 yards and I have this side length. So I have two sides. So I have two sides, and what I need, I don't know, let's see. It says find Vx. Well, Vx is right down here. And because I used X as one of the points on the circle, I'm going to use Y as the variable. Okay, so I need the third side. So I need the third side. Okay, well, again, where a tangent line meets a radius is a 90-degree angle. So I have a right triangle and I have two sides of that right triangle. So I'm going to use Pythagorean theorem. Okay, and then I have to identify, what am I solving for? Am I solving for a leg or am I solving for the hypotenuse? Well, directly across from the right angle is the hypotenuse. So that's what I'm solving for. I'm solving for the hypotenuse. So I'll do leg squared plus leg squared equals hypotenuse squared, which is y squared. Okay, a calculator will be your best friend at this point. I wanted to make sure to have a calculator, but apparently I didn't grab one. So I'll do this by hand. Okay, so 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. And then we need to get rid of the square on the y, because I just want y, I don't want y squared. So to get rid of the square on the y, what I'm going to do is I'll do the opposite of a square, which is a square root. So I will square root both sides. So the square and the square root will cancel. And I can take the square root of 169. Square root of 169 is 13. So I have my answer. So Vx is 13 yards. Okay, I'd ask any questions, but you guys can't ask that. This is a video, so I'll keep going. All right, so here's another where I was given, what I have is two sides, and what I need, right, because it says find the radius. This is the radius, okay? And again, I used X as one of the points, so I'll use Y as my variable. So I'll need that third side. Okay, but now I'm going to ask myself, is that third side going to be a leg or the hypotenuse? Because that's going to decide where I put these numbers for Pythagorean theorem, which I know I need to use because I have two sides and I need the third. Okay, well, the tangent and the radius make a right angle, and directly across from the right angle is the hypotenuse, the longest side. So 37 is my hypotenuse. It is the longest side. Okay, well, I had the hypotenuse, which means I am searching for a leg. So it'll be, I don't know, squared, because that's the leg I want. I guess I should use the variable I said was y. So y squared plus my other leg, 35 squared, equals my hypotenuse squared, 37 squared. Okay, so Miss Clem is good and she knows a whole lot of squares, but she does not know 35 squared. So I'm going to use a calculator for that. So y squared plus 1225 equals 1369. Okay, so if I'm solving for the y squared, okay, I need to get rid of this plus 1225 So I'm going to subtract 1,225 from both sides. And I will get y equals 144, or y squared equals. I don't know why I lost the squared from here to here. Okay, so now I need to get rid of the square purposely and not because I accidentally lost it. So I'm going to square root both sides. So y equals the square root of 144, and I actually know this one. Square root of 144 is 12. Okay, so my radius is 12. Okay, so if you're solving for a leg, you're going to end up subtracting. Now, if you wanted to subtract before you actually did the square, that's completely reasonable. So from up here, you could have subtracted 35 squared. Okay, now you didn't know what 35 squared was, but if you plugged it into a calculator like that, as y squared equals 37 squared minus 35 squared, if you plug this portion into a calculator, it would have just told you that y squared equals 144, and then you only had one step left. So either of those options is fine, whether you subtract before you square or after you square doesn't really affect the final answer, as long as you do the square before you actually combine these. All right, so on to this beauty over here, okay? So I forgot to say what we're looking for. Okay, so I want to know the measure of angle P. Okay, I want to know the measure of angle P. That's this variable up here. Okay, I want this portion. All right, well, here's the kicker. This is now a four-sided figure. This is no longer a triangle, right? I have 1, 2, 3, 4 sides. So how am I supposed to get the angle measures when I have a four-sided figure instead of three-sided figure? Well, we did the sum of the interior angles of a four-sided figure once upon a time. And if you can't remember, just think about the most common four-sided figure. Think about a square. Okay, so this is a square. It has 4 90-degree angles, right? That's what makes up a square. So if I take a handy dandy calculator and I do 4 times 90, I'll get 360. So the sum of interior angles is equal to 360 for a four-sided figure, okay? So now that I know what the total should be, I can use that and the angles I know to solve for the missing one I need, okay? Now here's the cue that you're supposed to take, okay? These are tangents, right? Both of these are tangents. Both of these are radiuses, which means that both of these angles will be a 90-degree because of the theorem that we have written down, discussed, and used throughout this whole video. Okay, so I have 2 90-degree angles and one 131-degree angle, and I want to know what my last one would have to be for all 4 of these to add to equal 360. So I'm going to take the 3 I know and add them together. So I get 311. Okay, so this whole bottom will equal 311 degrees. So I'll take the total I know it's supposed to be and subtract the angles I already know, and it should give me the angle I don't know. So this should be, borrow from the 6, 9, 49. Okay, so 49 degrees is what the measure of angle P should be. Okay, hopefully this makes sense. We did do the interior angle measures of four-sided figures once upon a time. We also did 6 or 10 or 12 or 18-sided figures. It didn't really matter. It always came from a formula. So here's how you'll solve these types. All right, I have 2 more and then I'm done. So the first one gives you something like this. It gives you a circle with a right angle, right? This is a tangent, if it's a tangent. So if this is actually tangent, so that's what it's asking. Is WX, this line up here, tangent to the circle? If it is tangent, then this angle has to be a 90-degree angle. Okay, so if it is tangent, this is a 90 degree, which means that I can use Pythagorean theorem to find these sides. So that's what we do. So to decide if a line is tangent to a circle, we will use Pythagorean theorem to prove it. Okay, so if Pythagorean theorem works for my numbers that were given to me, then these were tangent. It had to be, okay, because it had to be a right triangle. So 18 is a leg, 95 is a leg, and 96 is the hypotenuse. So it should be 18 squared plus 95 squared equals 96 squared. I have no idea if this is true, so I'm going to go figure it out using a handy dandy calculator. Okay, so 18 times 18 for 18 squared, 324. 95 times 95, wow, 9,025. 96 times 96, 9,216. Okay, so 324 plus the 9,025 is 9,349. So here's where I check. Is 9,349 equal to 9,216? Okay, the answer is no. Those are not the same numbers. So Pythagorean theorem failed, so it's not a tangent. So Pythagorean theorem failed. So Pythagorean theorem failed, so WX is not tangent to the circle. Okay. So on iExcel, this will just give you a yes, no. You don't have to write the words, but this is a video where I'm supposed to be helping you figure out how to do these, so I'm going to write the words. Okay. Now, because this is a video and you can pause, rewind, fast forward, I'm just going to keep going. All right, so the last one. So I have these two tangent lines that hit this circle, and they share this outside point W. Okay, there was a theorem about that. So let me go back to that theorem for just a second, because this is really, really important, but it's the first time we used the theorem. So it's really important that you guys either had it written down or you kept the PowerPoint up. So right here, it says two tangents that meet at some point outside of the circle are congruent. Okay, that means for me in my question, okay, that means for me in my question that this upper tangent is congruent to this lower tangent. These are congruent, they're the same, right? So if they are congruent, if they are the same, then they should be equal to each other. So 3x plus 2 equals 77. Okay, and then I'm going to use basic algebra to solve this. Okay, well, I want x alone, which means I do not want the plus 2. So I need to get rid of the plus 2. So the opposite of addition is subtraction. So I will subtract 2 from both sides so I can get rid of this. So 3x equals 75. Okay, now I just want x. I don't want the 3 times x. So to get rid of the 3 multiplied by x, I'm going to do the opposite of multiplication. The opposite of multiplication is division. So I will divide both sides by 3. Okay, and 75 divided by 3 is 25. So x is 25. So I hope this helps you out. Please feel free to email me if you need anything, and I will talk to you guys later.